I explain why we do this assumption. Remember that in isotropic medium, we have this relation. K is omega over C times refractive index. If you want the direction, you just multiply this quantity, this magnitude, to a unit vector along the wave vector direction and get the wave vector. However, we know that in anisotropic medium, the properties may be dependent on the direction. So, although we can still try to write K as omega over C times some quantity, we call it refractive index. However, this refractive index is unknown. Okay, it is different from the isotropic medium. In isotropic medium, the n is given. Okay, now you are not given n directly. You are given epsilon x, epsilon y, and epsilon z. And from experience, we know that epsilon x over epsilon 0, epsilon y over epsilon 0, and epsilon z over epsilon 0 represent some kind of square of refractive index. So we use this notation nx squared, ny squared, nz squared to represent the refractive index along the three directions. Okay. In fact, this nx, ny, and nz represent special situations. For example, if I consider an E vector along the z direction, okay? Suppose we have an E vector parallel to the z direction. Since z axis is a principal axis, we can simply write down dz equal to epsilon z times Ez. Okay, and in this case, we can even write d as epsilon z times E vector, because the d vector and the E vector have no other components. They have only z component. Okay, so if I replace the original anisotropic medium by an isotropic medium with epsilon equal to epsilon z, to the wave, the propagation is the same. Okay， 就是说你虽然本来是一个 anisotropic medium， 但是呢，因为你选的D vector、E vector 方向非常特殊，而它们刚好平行。它平行的时候，比例的常数刚好是这个 epsilon z， 我就偷天换日把 epsilon 这种原来的 anisotropic 介质换成一个 isotropic 介质，但是它的 epsilon 就是 epsilon z。那对这个波来讲，在这个特殊状况下，它的传播的行为是一模一样，没有差别，跟原来的是一样。OK， 好，跟原来就因为它没有感受到其他的 anisotropic 的分量对它的影响，所以在这个情况下，你可以很容易预测折射率是多少。折射率就是 epsilon z 除以 epsilon 0开根号。So in this very special situation, you can predict that the refractive index is nothing but this nz. Okay, so this 3 reference refractive index are for those special cases. OK， 好，就是你的那个传播方向，你的最主要不是看传播方向，主要是看你的 propagation 的方向。好 ，So we will discuss the details maybe next week. Okay, we can discuss the details about the propagation and the refractive index. Here you just treat these 3 quantities as some reference parameters. Okay, and remember, do not consider nx, ny, nz as some components of a vector. They are not. They are not components of some vector. They are just 3 reference refractive indices. Okay. So use these notations and substitute them into this equation and factor out omega over c to the 6th power and ignore this omega over c. You get this equation. You get this equation. And this equation can be further simplified.好，我们现在把这整个方程式每一项都除以这一个，好 ，So we divide the whole equation with this vector. So we get 1 plus n squared sx squared over nx squared minus n squared plus n squared sy squared over ny squared minus n squared plus n squared sz squared over nz squared minus n squared equal to 0. And finally we can write it as n squared minus nx squared plus sy squared over n squared minus ny squared plus sz squared over n squared minus nz squared equal to 1 over n squared. Okay, so this equation has a name.把这个方程式叫做Fresnel's equation of wave normals. Okay. So, what is the use of this equation? Okay. You consider an anisotropic medium. So you know these 3 reference refractive index. Okay. Then, if you want to know the refractive index corresponding to the propagation direction S, you just use this equation. Okay, you have Sx, Sy, and Sz, which determine the propagation direction. And use this information, you can solve n squared. Okay, once the n square being solved, you substitute this n, then you get the k vector. Okay. Although this form is is easier to remember than this form. In fact, when we want to solve the n squared, we still need to rewrite it as something like this. Okay, and what is the 就是说这究竟是几次方的方程式啊 ？You may see this as the n to the power of 6 equation, but in fact it is n to the power of 4. The fourth equation, fourth power equation. This is the fourth power equation. Okay. How to see that it is fourth power equation? 好，我们现在来看看它怎么样变成这个4次方的方程式哈。原因其实很简单哈，因为这里哈，你看啊 ，remember that we have sx squared plus sy squared plus sz squared equal to 1. Okay, so here, remember here we have 这样6次方，对不对？这样是不是会得到一个什么东西的？你这边 ，if we look for the 6th power of n, here we get minus n 的6次方啊 ，minus n to the power of 6, and here we have plus n to the power of 6 times sx squared plus sy squared plus sz squared. However, since the sum of these 3 squares is equal to 1, so they cancel to each other. 所以6次方其实是可以 cancel 掉的，好，剩下4次方。So finally, this equation is the 4th power equation. We may write this as a times n to the n 4th power n plus b times n squared plus c equal to 0 不会有奇数次方，都是偶数次方都是we have only even number power. OK 那这边的 A、B、C 会长成什么样子其实很容易写下来A, you can write down A, B, C coefficients 我有给你们一个 note 你们自己看一下So I have email and note about this to all of you yesterday. Okay, so you can find the coefficient A, B, C, or you just multiply. Expand this expression and to find A, B, C. Okay, so we know that if you check the A, B, C coefficient, then you will find that A is positive, and the B is negative, and the C is positive. In fact, C is just nx squared, ny squared times nz squared. Okay. C is just this. B is a negative number, and A is a positive number. Okay. So So we have an equation of this form: a n fourth power times b plus b n squared plus c equal to 0. We can solve n squared. N squared is equal to since b is negative, we can write this as okay, and it is obvious that this quantity inside this quantity is smaller than this. So the final result is always positive, but we get two different solutions. We get two solutions of n, which are equal to this. Okay. We get two solutions of this n. This implies that if we plot the K surface, we get a double shell structure. 就是说，我们如果把 K 向量画出来，给定一个 omega， 把所有的 K 向量画出来，我们会得到一个双层的结构。Two solution implies double shell structure, double shell surface。就是你把 K 画出来的话，它会是一个双层结构。我们如果把它画出来，我们画出来会长成这个样子。这边是 Kx， 这个是 Ky， 是 Kz。那一般来说的话，它会长成这个样子。这其实很不好画，但是呢，还是试着画一下。然后这个东西呢，它会变成这样。这其实是剖面图了啊，但是呢，就是说我们把它剖开来看的话是这样啊。 实际上是双层结构啊，双层结构啊 ，double shell structure 啊。那意思就是说呢，你给定一个 s 的方向的话，你把 k vector 指出去啊，就是说对一个固定的 omega for a given omega, if we want to find the corresponding k, we want to find the k correspond to the propagation direction s. We get two different K, K1 and K2. 这 1 2就是刚刚那个正负啊。K1 is equal to omega over c times n1 times s, and the K2 is equal to omega over c times n2 times s. Here, n1, 2 are the n plus minus, okay, the two solutions of the refracting indices, okay. 所以你这时候呢，就说你给定一个 omega， 你把所有可能的传播方向都考虑进去，你把所有这种对应到的 k 全部画出来的话，它会是一个很奇形怪状的一个双层结构。好 ，so if you consider fixed omega, fixed angular frequency, and you try to find all possible k vector corresponding to this omega, then the collection of all the k point form a double shell surface. OK， 好，会变成一个双层的表面，一个双层的曲面。好 ，double shell structure, double shell surface. OK，this double shell surface might be called normal surface. The normal surface. 就是关于那个 normal 的 surface 啊 ，normal surface 啊 ，Fresnel's equation with normal 好，那如果我们想要看得更仔细一点呢，为什么会形成这种东西啊 ？If I want to know why we have those very special point like this intersection. We can try to solve. We can try to solve this equation in the xz plane, xy plane, and the yz plane. Okay. So now we can study the intersection between these three planes and the cross section, the intersection between these possible planes and the surface and the normal surface. Okay, they will become very special kind of curves. Okay, in fact, for any one of the plane, we get one ellipse and one circle. Okay, but they are not. 它们不是 in general， 它们不是简单的球跟椭球的组合啊。But this surface is not simply the ellipsoid and sphere. However, if you consider a plane, you see the intersection between the plane and the surface contains one ellipse and one circle. OK， 好，那我们现在来看一下它究竟是怎样的椭球跟怎样的圆形。如果在那一步之前的话，我还要再稍微解释一下这个刚刚那个。还要解释一下刚刚那个所谓的 Fresnel's equation with normals 啊，Here I want to mention some important properties that you must be careful when you use the Fresnel's equation with normal. Okay. You remember that we have this equation. So we know that once you know the propagation direction, Sx, Sy, Sv, you can solve for the n squared. Okay. However, you must be very careful if we encounter the propagation direction to be along the principal axis. For example, consider S is equal to 1, 0, 0. Consider this special case. Here we have Sx equal to 1 and Sy equal to Sz equal to 0. If you substitute all these components into this original equation, you get something seems wrong. 1 over n squared minus nx squared plus 0 plus 0 equal to 1 over n squared. This cannot be correct. Okay? So there must be something special happen. Why is this? We know that if we consider not just substitute 0 into this equation, but consider the Sv, we may try this. Sx is equal to 1 minus delta. Delta is a very small quantity. And try, for example, Sy is equal to 这个平方会变成约等于1减2 delta， 所以这边大概是差不多是根号2 delta。Okay. If delta is very small, you can substitute something like this. Okay. 因为这个是0，如果这是0，然后这个平方是得到2 delta， 这个平方是1减2 delta。因为加上 delta 平方 ，delta 平方太小啊。If delta is very small, we can ignore the delta square 啊。So this square becomes 1 minus 2 delta, and this becomes 2 delta, and the sum of them becomes 1. OK。好，那所以在这个情况下，你知道说 Sy 很接近0，但不完全是0，啊，不完全是0，趋近于0。那趋近于0的时候，你就开始想到，我们从前是不是学过一种东西叫做洛必达 （the hospital method） 啊 ，to principle to find something like this 0 over 0，OK？ 洛必达路边摊哈，就可以上下微分，会得到某一个可能不是0的值嘛 ，OK？ 所以这你就可以猜得到，就是说，在这个情况下，会不会是？当 Sy 很接近0的时候 ，n 会很接近 ny。如果 n 很接近 ny 的时候，那这时候就变成0分之0的形式。那刚刚那个看起来不合理的式子就合理了啊。Something like this. Okay, so this may contribute something. So modify the incorrect equation to a correct result. Okay, so in fact. When you consider the propagation along some principal axis, this in fact implies the corresponding n take one of the two possible values along the perpendicular direction. Okay, say propagating along the x direction, then n may be equal to ny or equal to nz. OK， 它会是这两种情况的其中一种。但是呢，因为你原来这个写法，你其实很难去避免一些问题啦，就这可能会出现一些问题。所以遇到这种特殊情况，还是回归到原来那个4次方的方程式去解才是正途。好 ，So if you want to solve all the possible values of refractive index, the best way we use is to use this equation instead of using this equation, because you may get some trouble when using this equation. OK， 好，所以就是在那些特殊的方向上，你要特别小心啊，你不能直接用这个原来这个方程式哈，而是你要考虑把它乘回去哈，把它乘回原来那个4次的方程式哈。So you can always use this equation, but if you use this equation, you must be careful when you encounter the propagation direction along certain principal axis. Okay. 好，那接下来呢，我们就来看一下，在这些平面上面，我们究竟会看到什么曲线？好 ，so now I want to study what kind of curves we will find on the 3 possible planes. OK。这边的话呢，我就不把那个推导细节写完整啊 ，Note 里面有，大家可以自己 check 看看啊。这个我直接写下来是长这样，就 this equation will multiply this equation with the fourth power of omega over c. We get this times this A, B, C. This equation gives us k squared times nx squared kx squared plus ny squared ky squared plus nz squared kz squared minus 这个平方，然后 ny squared nz squared nx squared times kx squared, okay, plus nz squared plus nx squared ny squared times ky squared plus nx squared plus ny squared times nz squared kz squared plus the fourth power of omega over c times nx squared ny squared times nz squared equal to 0。好，这个其实还是 normal surface 在 K space 里面的方程式，看起来非常复杂。This is the equation describing the double shell structure in the K space. Okay. So for normal surface. So it looks complicated. So we can make it looks a little easier. 我们如果把它全部除以 nx 平方 ny 平方 nz 平方 we divide the whole equation by this factor, so we can find k squared times kx squared over ny squared nz squared plus ky squared over nz squared nx squared plus kz squared over nx squared ny squared minus Okay, so we have this equation. Okay. Now we consider the special case that on the one of the plane, coordinate plane. Before I do this calculation, we assume nx is smaller than ny, and ny is smaller than nz. OK， 好，我们假设它是这样的情况啊，就是我们有三个相反的三个不同的参考折射率，那我们把它排序哈。最低的叫 nx， 次低的叫 ny， 然后最高的叫 nz， 啊，然后我们就把这个定为 x、y、z 的三个方向，好。And now I consider the special case that ky is equal to 0. We consider this我们现在考虑 xz 平面啊 ，kx、kz plan 啊。好，这时候呢，因为你没有 ky 了嘛，所以你现在会有什么呢 ？ks square plus kz square is equal to k square. OK， 然后你的 ky 全部都设为0 ，ky 设为0，所以 ky is 0 now. ky is 0. So now we have ny square， 这边因为已经跟这项无关了，这边共同都会有个 ny 平方分之一，so we now have ny square in the denominator. Okay, so we have ny square k square over ny square times kx square over nz square plus kz square over nx square。第一项会长成这样。那第二项这边呢，会变成什么样子呢 ？Here we have 1 over ny square times kx square plus kz square. Oh, 这边我忘记乘那个 omega over c 的平方。这边有一个 omega over c. Here as a factor omega over c square. So we have k square over ny square plus kx square over nz square plus kz square over nx square. 这样，然后最后还有什么东西的？还有加 omega over c 4次方。So according to this equation, you can factor them as k square over ny square minus omega over c square times kx square over nz square plus ky squared, kz squared over nx squared minus omega over c squared equal to 0. So this implies that this gives us a solution k squared equal to omega over c squared times ny squared, or kx squared over nz squared plus kz squared over nx squared equal to omega over c squared. Okay. So this gives us a circle, and this equation gives us an ellipse. Okay. So in the kx kz plan, here we have kx and kz. Okay. The first equation gives us a circle of radius omega over c times ny, and this implies that corresponding to this curve, the refractive index is just ny. Okay, and for the second curve, we get an ellipse. Okay, so we have this one. When kz is equal to 0, we get kx equal to omega over c times nz. So this nz times omega over c. Okay, and this gives us nx times omega over c. Since we assume that nz is larger than nx, so this is the major axis and this is the minor axis. Okay. And the magnitude of ny is between nx and nz， 是在两者之间啊，所以 so say this is ny and this is ny, so we get a circle. So 画得很烂。从前有个说法，几何学就是对错误的图形做正确推理的技术。So this is a circle. Okay, and the radius of the circle is just ny omega over c. Okay. So in the kx-kz plan, we see the intersection between the circle and the ellipse. So we get 4 special points. 我们得到了4个特殊的点。Okay. We can also plot the corresponding curves on the say kx ky plan and the ky kz plan. The result, you can see the result page 91, figure 4.8. 大家可以看课本这个4.8的图啊，图4.8啊。那图4.8告诉你的是说，你看啊，会有这个交叉点的只有在 KX-KZ plan 啊，其他的都没有啊。So only in the KX-KZ plan you get these 4 special points as the intersection between the circle and the ellipse. In other plans of coordinate, you just get a bigger ellipse with a smaller circle, or bigger circle with a smaller ellipse. OK， 好，就是说你可能是看到一个大圆跟一个小椭圆，或是一个大椭圆对一个小圆啊，那都是一个把另外一个包在里面。那只有这个呢，这在 KX-KZ plan 呢，它是有交叉的啊。这是因为我们假设 NX、NY、NZ 的顺序是这样，如果我们把这个假设换掉，它的交叉就会发生在别的平面啊。The intersection happened in the KX-KZ plan because we assume that NX is smaller than NY and NY is smaller than NZ. If we change the order, then the intersection will happen on other coordinate plans. Okay. And then this special direction connecting the degenerated points. This special direction called optic axis. Okay, this is also be defined as optic axis. 所以光轴是什么？光轴就是这种交叉点啊，就是optic axis is the intersection between intersection of the circle and the ellipse. Okay, you have 2 optical axes. Okay, and the double shell structure has the symmetry, means that if we map Kx, Ky, Kz to other octant, we get the same shape. OK， 好，就是说我们现在把任何一个 K 呢，我们把任何一个分量变号的话，我们得到的形状是完全一样。好，就这个曲面的形状完全一样。好 ，so we have this kind of symmetry. You can map the 1/8 of the normal surface to other 1/8 of the normal surface. OK， 好，其他的1/8。好，总共有8个挂线。好，我们有8个挂线。任何一个挂线里面的 normal surface 的部分都跟别的地方长得一样。好，然后呢，我们会有4个这样特殊的点。好 ，we have 4 special point looks like a belly button. 好，就好像一个肚脐眼一样。好 ，something like this. 好，我们会有这样。然后呢，这个线条呢连接相对的这个肚脐眼呢，就是得到这个所谓光轴。好 the line connect to opposite belly button is called optic axis. So we have 2 optic axes. Okay, in general, if we have nx equal to ny or ny equal to nz, then the 2 optic axes will become 1. And in those cases, we encounter the so-called uniaxial crystal. The uniaxial means only one axis. OK， 好，那我们今天先讲到这里。